Assalamu alaikum, ladies and gentlemen, welcome back to another live stream. Alright, let me share the link. Please join my Discord server. You can find the link in the description so you can get notified of new streams and other stuff related to my channel. Okay, so live, righty. And yeah, there's always, like, when you start streaming, there's always some motorcycle coming out of nowhere in Morocco for some reason. That is just unavoidable. Whenever you start streaming, there should always be a motorcycle coming. Welcome to Morocco. Anyways, alright, so last stream we had a lot of fun with creating a math expression parser from, well, not entirely from scratch, but kinda. We're using, though, a library for functional parser combinators. Yeah. Okay, so I've done a little bit of changes offline, off camera. So first of all, I added the rust.yml GitHub workflow. It's just too simply so it automatically builds and run tests for the GitHub repo automatically after a GitHub, pull request or merge or whichever. So nothing crazy. Name Rust, on push branches master, pull request branches master, nv cargo term color always, jobs build, runs on Ubuntu latest, steps uses actions checkout, build, so cargo build dash dash verbose and cargo test dash dash verbose. As simple as that. And thanks to adding this right now, if we go to yeah, I shared the link. Okay, cool. So if we come to his, as you can see, it automatically tests and makes sure that everything is okay. And this actually was very useful, like, immediately when I added it, because the build have failed. In GitHub Action, the build have failed when I've done this. Hello, Theo Paris. Welcome to the live stream. How is it going? So that was very useful, but here, notice that right now it's actually a success. Look at that. And the problem that I had, why it didn't run, because I'm using Rust nightly, right? But the GitHub action doesn't know that, so by default it would use, just a Rust stable. So what I had to do to make sure I fix it is to add a rust-toolchain toml file. And so this would make anyone who compiles your Rust project, he would automatically use the nightly channel. Okay, and here I also have done another thing, which is add some basic evaluation error handling. Nothing crazy yet. So user CDOPs, okay. I also added the pub use chumskys, so I can basically expose the chumsky dependency from my library to people who uses my library, and you'll know why in a second, because right now we have the worst user experience on the planet because we haven't done that just yet. But yeah, anyways, so here we have eval. Okay, so instead of f64, before we had in wraps right here, so if the variable couldn't be found or the function couldn't be found, we would just basically crash the program, right? Which is not great for a library, you may not want that depending on our use case. You may want to actually handle that properly. So here, instead of return f64, we're returning a result f64 and then an eval error, which is too simply a enum and the find variable. Sir, and I should also add it here. Actually, I should fix that and derive debug pretty much. I should probably also implement error for this, so it becomes easier to handle as an error. But anyways, Other than that, so instead of identifier variables.getId.inwrap, and then we get a reference to that entry, and then we dereference to get the actual value. We don't do that now. We actually say variables.getId, yeah, same thing. But instead of the dereference, we actually say .map. So we map it. So if we have an OK result, we map it into dereferencing the OK result, right? So otherwise, if there happens an error, we're gonna say eval error and define variable ID. So we're just gonna give it this ID right here. And then of course we use this interrogation mark to, if there is an error, if an error happens here, we basically return immediately from the function with that error, essentially. So it's simple as that. So we propagate the error back into the caller. Okay, cool. So here again, of course, this is a recursive call eval, and if that eval have succeeded, we map that success value to -x. Otherwise, of course, we error once again. So the same thing is going to happen on the other ones. Hold on, let me, oops, okay. All right, so we have add, same thing, subtract, same thing, multiply, divide, blah, blah. Anyways, the other thing is this call expression. So we get the function using that name index. Actually, hold on a second. Why we're not using .get here? Yeah, that's why we don't get an. I see. Anyways, we'll change this in a second. All right, so here we got the arguments. We iterate through them and we map them into evaluating the arguments. So we evaluate the arguments, then we call the function, of course. So collect, and then we collect it into a result vec. Now notice here, if we just collect normally into a vec, what would happen is that we're gonna get a vector of results because eval returns a result, right? Which is not great. Well, what we actually want is, at least in this case, I mean, you can handle it however you want. When we get the first error of evaluation for these arguments, what we do is to simply like return immediately with an error out of this collect function, right? And it does that because here in the signature I've told it to return for me a result, and if it's success, then give me a vector of whichever argument that is, which is going to be, of course, expression in this case, and error otherwise. So that's, and of course I propagate the error back. Great. So that's just simply it. Other than that, what I've done here, yeah, I've just right now I just inwrap. Though it may be better if I say that this should be OK identifier hello instead of inwrapping. But anyways, there you go. So that's what I've done on that other commit. The other thing, then I basically made another little commit that because I ran cargo clippy, and I actually forgot about this copied iterator thing, right? So instead of saying .map and then dereference the element, you just say .copied like this. This is what cargo clippy have told me. And actually I knew this before, I just forgot about it completely. All right, and the other thing that I've added a folder called examples right here. Right, and I called it basic.rs. Now this is an example if you want to actually use the library yourself in your own project. So like you would just say cargo add dash dash get, you would, you know, cargo add dash dash get, you would paste the link of the GitHub repo of Kodotaku math expression parser, right? And then it would be added to your project, and then you would do something like this for now at least, though it will make this better in a second, hopefully. So and here is why I needed to make that to make public import for chumsky, because you need the parser to be able to call it, you know, and such, to use parse with state. Yeah, to use parse with state function, which is part of this parser trait in chumsky. So if I didn't, that wouldn't really work out, unless if you import chumsky yourself, and then you have to make sure that you have the same chumsky as the one that the library uses. Otherwise you may have some incompatibility, etc., which is not great. Either way, there you go. So we create a parser, we parse with state, you know, do whichever mathematical expression here. The state, this is not being used right now, but we're going to use it probably in this stream to optimize some stuff. Here we define some variables, we make a hash map with the values in it, we define some functions, and we put it into a hash map too. And then we evaluate the expression, and then finally we test the result to make sure it's correct. Though of course you're not going to do this yourself, you're probably going to do whatever you want with the result. So result, it's equals, so basically here I'm using Rust itself, so this is what that expression translates to in Rust, and there you go, and just make sure that works. So right now if you are working on this library directly, you just say cargo r dash dash example basic. We're gonna make some more advanced examples later on, maybe like a REPL for running expressions, but we'll see. And there you go, you get this, so the result, and here's the AST too. Pretty cool stuff, lovely. So is there anything I've done already? Yeah, I probably did, let me see. Okay, at a basic, actually yeah, that's pretty much the last one I've done off camera. Okay, great. So I'm pretty excited for today because I think we're gonna be doing some optimizations. Is the stream fine, by the way? Please let me know if the quality of the stream is fine. But yeah, today I'll try to do some optimization. To be honest, it's kind of scary. I'm not sure if I'm gonna be able to figure this out, how this would go. But I mean, the best way to advance is to get out of your comfort zone, I guess. Anyways, let's go ahead and try to do this. So the first thing that I really want to optimize out right here is these boxes. For every box of these, we're making a new allocation on the heap, which is horrible, right? So what I'd like to hopefully be able to do is to optimize this out into somehow, right? And it's actually not that easy to do in Rust, because of course you gotta make sure, like, basically to prove to the compiler that what you're doing is sane. And when it comes to such tree data structures with self-referential tree data structure, is kind of crazy when it comes to Rust. But there is some easier solutions, right? So I think it may work if we use like if we made use of a library that gives us, like, what is it called, a bump allocator. So and that would probably fix our lifetime issues and stuff and make it possible for us to do such a thing in a good way, right? There's Bumpalo, right? Bumpalo, and there's some other libraries too. But honestly, I don't think I'm gonna go with this either, cause if I go with this, I'm gonna make this into a reference anyways, and I have to add maybe another lifetime, and I have to basically go ahead and edit the lifetimes through all my code base once again, which is a pain in the ass. So for now at least, what I'm thinking to do right now to optimize this is to use my state that we introduced in the last stream. So the state right here, to keep track of a vector of tokens, right? Well, not tokens. I don't know what you call this. Expressions, right? A vector of expressions. And instead of allocating on the heap with a box, we would just push it into the vector, right? And then you would store the index of that expression in the enum instead of a box. So that's what I'm thinking to do today. The only problem I see with this, at least for now, I mean, there is some other problems, like if you want to make the tree, if you want to like change the tree, like removing and inserting is going to be a pain with this method. But yeah, and the other one that I'm really concerned about right now is the fact that if I do this, I would probably not be able to use operator overloading anymore, because I don't have access to the state here in operator overloading, unless if I maybe make this expression into a struct, right, and store with it possibly a reference to the state, maybe, but I don't know if that's really good, honestly. I'm not entirely sure, but yeah, it's either optimization, I guess, or this. I'm not honestly sure what I'm gonna go with, but I mean, I honestly would not like to lose this, so maybe we could start with that and see how it goes. And like you would maybe store mutable state, and then you would have the actual expression enum. So I'm not sure what I'm gonna call this. Stateful expression. Okay, stateful expression, and then we'll have our expression. Maybe, I'm not sure how good would that work. Seems like I'm gonna have to do the lifetime anyways, but I don't think it would be as bad as doing it here. Maybe, hopefully I'm not wrong. So state is never constructed. Okay, cool. So right now we have to change well, not exactly everywhere, but yeah. Actually, yeah. We do. We have to actually do it here. That's interesting. That's interesting. I think I'm gonna sacrifice the operator overloading, honestly. This doesn't seem to be that easy to do, not gonna lie. So did I pull my changes? Oh, hold on a second, let me make sure I'm in the latest branch. I think I am, but anyways, let's put this in top and on the top right there. Also this one too, and this one. Let's put them out of here. Okay, cool. Let me just, and yeah, there's another thing that I'd like to do before this crazy change, is this undefined function. Actually, let's fix this for a sec. There you go. And where we should do this, yeah, here. So instead of just doing this, we're gonna probably say get name, expected function found option. Yeah, so in wrap, or we're gonna actually say map, right? So map, and we basically get the function that we want, and then we could use it in the case of and we just unwrap that thing. Okay, hold on a second. So we get a function here, right? Hold on, where's f? There you go. Yeah, it's a reference though to a function. Would the reference still work? Maybe. Anyways, so yeah, this is becoming a bit of a spaghetti here. What's up? F arguments map. Yeah, in wrap or maybe, or okay, or just like I've done there actually, I think. Okay, or eval error undefined. And let me try to run this test. Undefined Oh, okay, gotcha. Nice. And here, what's up? Can only be used to return results on an option. Oh crap, I see. Because this became right now a closure, so I can't propagate this back. This is the only thing I hate about results as values. When you put them in a closure, right now you have to figure out how to deal with them. So do we actually want it here? Yeah, we do. I mean, it's a result, right? So F. Well, we could say in wrap, but that's problematic. Okay, here's the deal. I think what I'm gonna do first is collect that stuff, then map it again. Right? And there I'm gonna get to my arguments. Then we're gonna map it. And what else? And let's just unwrap for a second. Okay. Well, map. What we're supposed to return here? Oh, nothing, yeah. Nothing, my bad. Let's see. What's up now? Operator is incompatible types. Cannot convert from to F64. Oh yeah, my bad. I see. Oopsies, what I've done there. I see. We have to return the results of calling the function, which makes sense, yeah. But otherwise, what we should do, we should... Well, doesn't this give out a result anyways? Interesting. In wrap. Oh yeah, I see. So we basically want to give that as a error. So this is interesting. So right now we're actually having an option result F64 eval error, which is interesting. Can I do this? Okay, or oh, maybe I can map it here. Does that make any sense? Yeah, how can I return it? Actually, after this, yeah, my bad. After this, after we have done this, maybe we can then do this again. Okay. Because like here we have like nested errors, which really confused me. I never worked with this before. Okay. All right, cool. So right now we have fixed that. Right now, if there is some variable, like if we have gone to our example, right? And if we run this right now, right? If we run this example, there you go, it works. But let's say in the expression we have some variable that is not defined. Let's see what's gonna happen. And we unwrapped on an error value in defined variable hello. Let's go. So it works perfectly. What if it's a function instead? in the find function, hello. Let's go. That's great. Cool. Now, why we needed that nested error business is because, let's say you have the cosine, right, which is perfectly fine. But if you have, let's say, some variable that you don't know inside of that cosine as an argument, then you have to propagate back that error from the argument back to the main one. But anyways, undefined variable, hello. Either way, it works right now. Great. Perfect. Perfect. Okay, cool. So we have fixed that error chicken right there. Is there any other error stuff that we want to fix? We probably want to make that into OKs. Let's do that. So instead of in wrap, you would just assert that it's equal to OK, meaning that you have, successfully done it. Mismatched types, parse result. Huh? Found enum result expression. What? I'm confused. Expected parser result. Oh, I see. Gotcha. So this should be into result. I'm not sure why they're using their own result type. Anyways, so I have to actually do this right now. So instead of in wrap, you say dot into result, and then you can say OK number into. I'm not sure if GitHub Copilot could do this refactoring because it's tedious. But let's see if he could do it. Refactor this like to handle errors like the previous assertq. Let's see. I think it did, right? Though it did add one thing, I guess, which is it added the interesting. Anyways, honestly, let's just do it ourselves. I don't want to proofread after the AI right now. Okay. And here into results. Oh crap, come on. And okay. So instead of enwrapping in the test, we would just get a proper assert message. So okay. And this would also allow us to test for errors, like to assert for some things that should actually throw an error, like some illegal syntax, to make sure that it does indeed throw an error, that we're not there yet. So yeah, into result. Okay, and into result. Oh man, this is very tedious. Oh crap, 3 more. This sucks. Okay. Into result. Well, actually, hold on a second. What I'm doing, I should have done this before, but well. Let's just do multiple cursors here and there, and do this. No, that wouldn't work. Okay, so let's just close this now. Let's close this. I think that's it, isn't it? Okay, and let's just make this into result. Yeah, where's into result? There you go. Oh, no method named into result. Oh, so what's up? Binary operation cannot be applied to type result F64 eval error, but why? Maybe because the error isn't, hold on, expected F64 found result. Let's remove these in wraps first. Let's see what it's gonna say. Must implement partial, yeah, that's what I expected. So this error should implement partial EQ. I don't know if you want EQ honestly, but anyways. Cargo T, let's go. Alright, so that works. Great. But how do we handle errors there? Oh yeah, that's good actually. And yep, pretty much. Now we can't possibly do something like this. And this is the example, of course. Okay. And then we would just say parse with state, huh? No, not this. In the eval, instead of in wrap, can we do this? Now, this wouldn't work. The trait bound eval error, std error is not satisfied. Following other types implement trait from. So this is the problem. I've done this intentionally to show you what is the problem here is the fact that we cannot use this on such like as a regular Rust error because it doesn't implement the error trait. So we gotta implement that. Now, instead of doing that on our own, I would probably use a library like this error to make this way simpler. So crates.io, it's called this error, though I've never actually used it honestly myself, but we're gonna do that today. Okay, so the library provides a convenient derived macro for the standard library std error trait. So cargo add this area. Cargo add this error. Great. And now how do we do this? We just derive error. So it makes it that simple instead of implementing everything yourself. And as our library, you're gonna have a lot of errors, so you really don't want to do that by hand. Cannot find the derived mac. Yeah, let's import the error from, well, no. Let's actually compile this. Okay, cool. Now let's just import that derive macro, and there you go. Now eval src doesn't implement stdfmt display. Makes sense. I think we can basically give it disconnect from IO error. Yeah, I think we should give it like errors like this, you know. If they don't implement FMT display, you basically gotta do it yourself then. So here you would say, I guess, in the find variable. And yeah, apparently you can also say use the argument that is inside of the enum. And this is a macro in Rust. So in the find variable 0, right? Okay, and here to in the find function. And there you go. Great. It's that simple. And there's also you can also do it this way. There you go. So you could say here expect, because this is a struct, you know, expected and then use the formatter. Oh, interesting. Use the debug formatter. Cool. Yeah, that's pretty cool actually. What is this from though? The from attribute always implies that the same field is source. So you don't ever need to specify both attributes. What? The implements are the reference, so work as a source. A from implementation generates for each variant containing a from attribute. Note that the variant must not contain any other fields beyond the source error and possibly a backtrace. I'm not sure what that from is for. There is even this backtrace. But yeah, this should be fine for me for now. And let's actually test this. Come on. And there you go. Now let's try our test real quick here. And well, of course, cargo r dash dash example basic. And let's go with, what is it called? Yeah, let's add some undefined variable with an, well, let's start with there, I guess. And there you go, you get an error in defined variable hello. Though why didn't use the format that we have told it to? Weird. No clue. Should have done it. Interesting. Not sure why that's the case. Either way, so this works for now. Alright, let's go back to our business here. Alright, is there anything else that I want to do on that part? So we can go to crazier parts right now. I think we're good for now with this. Okay, so let me just commit this real quick. So what we have done, we just improved error handling, I think, for now. Oh crap, have that, what? No, never mind. Okay, good. So let's add all of these, and what's the basic RS problem? Oh, I see. Okay. So yeah, we're just gonna say improve error handling, and there you go, commit it. And we don't need to sync changes for now. So now let's go to the next task. And yeah, let's just do this. Let's optimize this up. Okay, so how are we gonna do this? Let's see. Where's our stage struct? There you go. So here we're gonna store our expressions in a vec expression, and it's gonna have the lifetime here, src. Let's change this. Is there anything else we want to do here? No, doesn't seem like it. Seems good to me. Oh yeah, by the way, I've also have incommented this, so I can make sure that nothing is being in used. There you go. Okay, cool. All right, so now let's make use of this. Okay, this is gonna be wild. So instead of box expression src, right now we're just gonna store a usize. Usize, usize, usize. A lot of usizes. Right, anything else? Vec expression src. Is there anything else? No, doesn't seem like, I guess. And can't you just find and replace Dragon F? Welcome to the live stream. I don't know. I'd rather not for now because we're doing something kind of icky. So we'll have to comment this out for now. And let's see what we're gonna do. Oh crap, we have a lot to change. Okay. Well, let's implement a function into this actually. Let's implement a function. I'm gonna comment this out, and I'm only gonna comment this part right here. Or, you know what? Instead of doing that, I'm gonna keep this like that. And instead of returning a boxed expression, I'm gonna return a usize. Hey, been seeing your Ash videos, helped me a lot. Thanks, thank you so much. Thanks. Glad it helped. Okay. So we also gonna need the state right here. We're gonna need access to the state. Immutable access to the state, or yeah. Honestly, we only need immutable access to the vector that we can put this expression in. Missing type for function. Oh yeah. So this is our expressions. Right. Great. And we're basically going to store the index that we're going to push into. We're going to push self, and we're going to return an index. There you go. Method defined here. Hopefully this is all we actually need to do this. That would be cool. Expected one. Oh, I still need some arguments right there. Okay, hold on. Dot boxed. Oh crap, I'm gonna need to do some other stuff too. So let's start with one part first. So instead of map, we're gonna make use of map with, and this would give us the state. Oh, it gives us this map thing. I don't know what is that. Either way, we can say right now the boxed mutable e.state dot expressions. There you go. Or honestly, map extra. Or we could just keep it as state e.state, and then here, instead of taking that, where is that thing? Here, instead of getting vecself, we can say mutable. So this would be the state, mutable state. Oh crap, no. Say it like this, okay. And we're gonna say state dot expressions, yeah, dot len, and state dot expressions dot push self. Explicit. Why a lifetime is required right now? Explicit lifetime required type lifetime source required. Interesting. No thanks. I'm not gonna go that path. Yeah, that's why I've done it this way at first, because I really felt there's gonna be some problem with the borrow checker. So okay, because basically the borrow checker pushes you to keep your reference into the smallest scope possible. But yeah, method defined here. So instead of like getting the whole state, which you don't need, you can just, but hold on, actually no, maybe it's actually that simple. Hold on, go back. Maybe I just have to actually say src here. No, yeah, I actually have to just do that. Interesting. Okay, All right, cool. Fine. And now let's just work this out. Boxed. So right now we're just gonna basically have to do this. I really thought there would be a problem with the borrow checker. Average Rust experience. Exactly. So with Rust, like dealing with the borrow checker is like, you know, going to the gym to make muscles. That's basically how it goes. So the more you train, the more you get better at it. Basically, it's predicting it and dealing with it at least. Yeah, mutable E state. But yeah, I had nightmares with the borrow checker, and I still do sometimes from time to time with more advanced stuff, especially with lifetimes. But yeah. Number dot boxed, mutable E state, and then map width, and we get the E. Oh, what is this? E. Is that how it goes? Okay, I see. So let's remove this out of here, and it's actually a separate thing, separate argument. Okay. Type annotations needed, cannot infer type. Huh. Really? Map width. That's weird. Comma. Let's leave that for now until later, and we can see how that goes. Number boxed. And expression dot boxed. Cool. And right now what we need, mismatched types, expected fn pointer, fn box expression. What the heck? Let me test this. Alrighty, let's see what we got. Yeah, hold on a second. One thing that I know for sure would mess up, we're gonna change this whole thing because we don't have operator overload in it anymore, which is sad. But well, for now we're gonna work blind without any tests. I don't really know how I'm gonna go with that, but we'll see. Maybe we could use some sort of a static variable for testing purposes, or some thread local. I don't know. We'll see. In used variable state. Okay, let's try this. And let me see the compile error. Expected expression found usize. Okay, go up. Hold on, clear and cargo T. Oops. Oh, I'm not on Linux. Okay. Remove this mute. Let's go up. Okay. Type annotation is needed. An expected fn pointer found enum constructor. Really? Oh, I see. But hold on. Yeah, maybe the binary parser go there. Binary operator. Oh yeah, there you go. So instead of box expression, right now we have usize. Okay, anything else? Let's see. Arguments to this function are well, that's true. So instead of box new, say boxed. B.boxed. Expected one argument found. Oh yeah. Man. Mutable a.state, and fold L, is it? Yes. Fold L with state. And then I think we're gonna get E here. And there you go. Cool. Cool, cool, cool. And yeah. So we fixed that one. What else? Here too. Same problem. So honestly, I'm just gonna copy this over and have an E here. And where's that thing with, yeah, with here. I'm missing closing delimiter. Interesting. Enclosed expected R param. Okay, cool. And hopefully that works. Okay, what's next? Alrighty. Mismatch types, expected reference, expression found reference, usize. Okay. Alrighty. How we're gonna even fix this? Let's see. So yeah, eval is expecting a reference to an expression. Oh yeah, but it's getting usize. Interesting. So one way I think we can fix this is either by doing the work here or just changing this to maybe usize. I think I would go with usize here. Expected usize found expression. Mismatch types, expected usize found that. So yeah, N. Huh. Now I'm confused. Where's the expression? Match expression. Well, right now we shouldn't actually do this that way. We should right now get the state, yeah? Oh, the state is part of the parser? Makes sense, yeah? But we also need it here. I think, and then we could say maybe state dot expressions expression type F64 cannot be dereferenced. Okay. Why do we don't need the dereference anymore? That's in, oh yeah, because this was, I think, a reference to an expression. And honestly, I don't want that. I want this, kinda. No. Yeah. And, okay. So what's up now? Expected 4 arguments. Okay, gotcha. So add in the state. And honestly, maybe we're gonna merge the variables and the functions into the state too, because why not, I guess. Or maybe a bad idea. I don't know. State. This is what you get for optimizations. Mismatch types expected usize found reference to usize. Well, it's fine. The nice thing that these are just indices, so if you just copy them, it's fine. Data moved here. Okay, but is that a problem? I don't think it is a problem, or is it? Okay, let's try this. So what's up now? Cannot move out of index of vec expression. Well, can't you just copy it? I mean, it's just an expression, nothing fancy, I guess. Or is it? No method found for. Let's implement clone for expression. Oh, where is the expression? Okay. So would that work? I think it's fine to clone this. I mean, you're just gonna clone. Well, I mean, if it works for now. I mean, we could get it, match it by reference, but where is it? I forgot where I was now. I think it was match expression. Oh, there you go. So it was here, dot clone. Okay, so that got fixed. Great. Okay, what else? Now this weird thing is telling me that type annotation is needed. I'm not sure why that's the case. And the following is not a parser from source to expression source. What the F? Oh, is it? Hold on. Weird. And please don't annoy me with your warnings. Cargo T. So cannot infer the type. Type annotation is needed. The following is not a parser from source to expression source. Recursive stir. Oh, it is actually returning new size. Interesting. Okay, where is this? Interesting. Well, where is it returning that? So here we multiply number. This is interesting. So what I'm expecting here, okay. So we have number. What is number? Oh crap. Number parser, okay. Number boxed. Map with the number and then expression. That is interesting. Maybe I should box this multiply? No? But why did it work here but not here? Good question. Like if I box this here, would this work by any chance? It's not found in this scope, huh? Yeah, e.state. Interesting. Recursive usize. So we're returning usize somewhere. That is interesting. I mean, I know the problem, but where is it? Did we fix that thing? Hold on a second. Parser error. Yeah, we do have the state there, which is good. Okay. Collect delimited by. Okay, what if I comment this out? Everything becomes a problem. Okay. The following is not a parser from stir to expression. Well, here's the case. So go back. Okay, and here's the thing. I'm gonna make this clear. Recursive, because this is the problem with like, you know, automatically inferring stuff. It's harder to track down stuff when you're. Anyways, usize. So instead of usize, what we really want here is, hold on, what? Input. Which, so this should be char, right? This is supposed to be char. Okay. And now what? Yeah, right now we have one problem here in the call function. Interestingly. Type mismatch in function argument. Expected function signature. fn found function. Huh. Hold on, what the heck? So expected function signature vector. What are you even talking about? Oh, hold on. Collect into a vector, right? And I think this. Really? Hold on. Let me make sure that this is, first of all, is good to go. Yeah, it's a vector of usizes. Okay, but why we have a problem there? So let me do this manually. So you have the name and you have the arguments, right? And the arguments is a vector in this case, which is weird. So then maybe recursive is supposed to be size? What? Well, isn't this actually supposed to be an expression though? Yeah, this is the input, sure, maybe. Well, hold on a second. Let me go to here. Well, not here. I need an example. Hold on. Where is recursive stuff? Because I need to see an example of the signature of that recursive type. Okay, but no, it's not providing that. Man. Well, what if I do this one actually? Yeah, this one just infers it too. But here's the deal. I can do this, right? And try to figure it out. Oops. Crap, you cannot remove that. Oh, what? Okay. Man, I just want to know what's the type of this. That's interesting. Well, here's the deal. How can I actually put this? Yeah, let's actually open up another terminal, another window, right? Let's open up another window, and let me go to. Let me even just clone my thing from start, really. So why not? Where is it? Okay, hold on. Because I need to see something real quick. Cargo add, well, no. Git clone, yeah. Oh yeah, already exists. I don't remember how do you do that, but let's just make a folder, go inside of it, and just clone it there. Anyways, oops. Where did it go? What the heck? Did it just crash or what? Weird. Oh, it actually launched here. What the heck? Okay. That is wild. Alright. So code into code of Chaco math expression parser. And yeah, we have a new window. Great. So this is our working code. Cool. So let's go down to recursive. Okay, here we go. So what is the... Okay, the Rust analyzer is still working on it. And let's see the type of this. Come on. Okay, what is the type of this expression? Alright, so it's, there you go. Okay, cool. So it's recursive dyn parser stir expression. Let's take this, please. And let's go here. Is this supposed to be here? Yeah, it is. Okay. And what's up now? Actually, just go back to what it was. And just change this to expression, please. Okay, great. So this is what it's supposed to be. Okay, and now we're actually getting a vector of expressions here. Why? Because we're saying expression clone. I'm losing my mind right now. Collect into a vector. Oh, actually, hold on. What the heck? Maybe we're just supposed to just store an expression here. I mean, we already have a vector there, right? Is that the case? Maybe? Kind of confused, honestly. This method takes 1 argument, but 0 arguments were supplied. Makes sense. Closure, oh yeah, folder with. Anything else? Mismatch type, expected use size, found expression. Oh well. Oh crap. Okay. Okay. So now our eval function is expecting a use size, but we have an expression. Great. Perfect. Okay, we could do something for now, which is to basically box that expression. Where is our state? Oh yeah, we already have our state, right? Yes. So we're just gonna give it the state directly, I think. Expected mute state found state. Ooh. Ew. Okay, let's see. Excuse me, no errors? Are you sure about that? Let's see. What? I mean, you said no errors. This function takes 4 arguments, but 3. Huh? Oh, it's in the example. I see. So, can you say this? Mute state. And here's our state right now. Let state is equal to, oopsie, state default. Yeah. And mismatch type is expected use size found expression, which is to be expected. But I really just want to build the library right now. Yeah, it builds, which is great. Okay. So now we have this AST, but if we want to make this work, we need to box it. But we don't have access to that function, I see. I mean, we're not supposed to as a user, but for now, let's just do it. Boxed state. Cannot borrow as mutable. Mute state, and is that it? Huh. So cargo r dash dash example basic. It works, I think. Yeah, it does. Great. Okay. So we don't have all that crazy allocations anymore. Though, as you can see, this broke. So it no longer shows us the whole thing. It just shows us in this case that it's an add with index 8 and index 9. So yeah, I have some problems here, first of all, which is probably what I'm going to do. Instead of expression usize, I'm just going to take an expression directly, I think, and then basically do the lookup in these eval functions. Now I did it this way before because I didn't want to do it manually for every one of these, but well, it sounds like a bad call for me here. But can I yeah, let's try this out, I guess. And so instead of usize, we're gonna get an expression, and then how we're supposed to do this? Well, of course, match expression and found if 64. Okay, do this. Now eval. Okay, cool. So found reference expression, expected reference expression. Okay, so here we're actually gonna do it. So we're gonna say state dot variables. Sorry, expressions. And I'm not gonna bother with the thing not existing. So state dot expressions index, and I think A is the index, right? In this case, state dot expressions expected found. Oh, I see. Do I actually need this? Yeah, I do. Okay, cool. But I could do it this way too, maybe? No, I can't. But maybe I could do it this way then. And then I wouldn't need this, or is it? No, interesting. That's weird. Okay, fine. And so this is basically it. So we're just gonna say this now. So this is why I took usize instead, just to avoid putting this old stuff like this, but well. Anyways. More spaghetti. Welcome to the world of refactoring. This is probably one of the few times that I actually refactored a project. Let's see, mismatch types, expected expression, found usize, arc.box. Yeah, so right now we're not gonna need the boxed anymore here, which is great. And what the heck? Bruh. What? Something is weird going on here. What the heck? I don't want the state to be that way anymore. And explicit lifetime required in source. What? So variables, get ID copied, okay. Huh. So what is the problem? Let's try. So help add explicit lifetime source to type of oh, I see. Is that it? I think it is. And now we don't need this hacky thing anymore, hopefully. And we don't need, actually we do need mutable, yeah. But we don't need mutable here in the evaluation. Oh. Left, not a number. Right, 1.8. Okay. So, what is the problem? Oh, I already see what is the problem. So, copy paste job done wrong. Okay. There you go. It works now. Perfect. Okay. Now, another great thing about this, though, is the fact that we can right now go ahead and like print how much stuff we have allocated through that expression. So like we could say state dot what is it called, expressions, but that gotta be a public thing right now. Okay, let's just make it public for a second. Okay, what if I do this? And yeah, for this particular expression, where is it? Yeah, this right here. We would have actually allocated 10 boxes, but right now we're just doing it in, we're just pushing them into the vector instead, pretty much. So that's great. And of course, this would grow as much as the thing grows. Now, the thing that puzzles me here is this vec expression src, though. So we're still having one allocation in the expression itself, which is for the vector. Can we actually get rid of this? Does it even make sense, though? Does it even make any sense? Call. Welcome to the world of optimization. Where we are using this? Okay, here and here. Okay, we're actually collecting them into a vector of expressions. Oh, I think I got it. Hold on, now go here, please. I think I got it. So, collect vec. So can we map this? And I think we're gonna get expression, right? Is that the case? What? We're not getting expression. There. What about here? Any chance? Nope. Here? Maybe? We are getting an expression here. But is it really what we want? I don't think so. So how do I run... How do I map this? Weird. I mean, I should be able to do map though. Weird. expression. So basically my idea is we should be able to map the expression into expression.boxed mutable mutable, and I need to get the state somehow. Then width. Oh crap, there's no width state here? Really? I think that would give me the context, not the state. Or is it? Prefer ignore with context, empathy, context. Yeah, I don't think that's gonna give me the state, or would it? Well, I guess we gotta try it out, maybe. So then that would mean, I think we're gonna need right now a closure, right? It's gonna give us the, oops, it's gonna give us the E. E.state. The following is not a oh crap, no, that's not really exactly what I'm looking for. Well, this suck. Okay, go back. Maybe I could see how the collect function works. Nah, it's a primitive. How do I before I collect? Crazy. Is that even possible? Oh, am I that stupid? Hold on. No, dot map. But I mean, I tried that. No. Yeah, no clue, honestly. Not sure how I can do that. Collect vec. What if I do a map here instead? Okay, here I do get a vector expression. But I mean, I have allocated the vector already. So no, thanks. It doesn't worth it. I think, at least for what we have here. So do we have some other form of collect? No, not collect exactly. Yeah, I don't think, I cannot think of a way to do this. Maybe I could look up the Chumsky parsers that we have. Maybe I missed one. Chumsky parser. Rust. Chumsky. Let's see the guide. Where it was. I think it was in here. Okay, cool. So just none of one of any. Then or ignore then. Okay. All right. So collect is here, right? So we can count the thing, or we could say 2. Or map with. Or map. But we tried map, but it doesn't seem like it's working out. Huh. Was that correct? But yeah, basically what I'm expecting to happen here is we would say map with, right? And hopefully would get the E2. And then we would to simply say E dot. But if you come to think about E dot state dot expressions, but if you come to think about it, we're gonna need a vector anyways, I guess. Yeah, anyways, never mind. I just waste time on this. So if anyone have any idea how to make this better, let me know, but I cannot really think of anything like that right now. What the heck? Hold on a second. What is going? Oh. Really? I'm actually editing. I'm editing the wrong thing. Yeah, I was editing the wrong thing. Seems like. But I think it's the same, right? Yeah, I don't think that changed anything really. So okay, cool. So what we have done so far. So parse with state. Okay. So great. Great. Okay, let's stage these changes for now. Let's make sure everything works. Okay, cool. So optimize allocations. And let's commit. Commit. Okay, so the other thing that right now I have to think about is, as I said, the fact that we do not have access to the state when it comes to this guy, to operator overloading. Because I would need access, like for example, let's say we have negate, right? So if I do this, right, and now box would need the state, right? It would need mutable state, but I don't have access to it here. I need somehow to get the state using operator overloading if I want to keep on using these this way of testing, right? Okay. So what I'm thinking is maybe we could have some way to be able to do this with some sort of a static. It wouldn't be recommended to be used like that, but like if you're like, it would be convenient for writing tests and stuff like that for the library itself. I never made a static kind of variable in Rust in my life because I just never needed it. But right now I feel like it really worth lazy static. Not sure if this is really what I'm looking for. A macro for declaring lazily evaluated statics. Using this macro, it is possible to have statics that require the code to be executed at runtime in order to be initialized. This includes anything requiring heap allocations like vectors or hash maps, as well as anything that requires function calls to be computed. For a given ref, this macro generates implements. Okay. So you do it like this. And then I think you could use it anywhere. Maybe. Well, let's try it. But does it allow for mutation though? Not sure. But let's try this out. So cargo add lazy static, right? Yeah. I'd never used this in my life. Let's see. Okay. Right. And now what we're gonna need is this. Something like this. Lazy static, and so I want to store the state. That's gonna be the type, and so this is the state is equal to a state default, I think, or default, and we don't need this. Consider importing, okay, sure. But would it allow us to mutate it? That is the impl item signature doesn't match trade. Huh? What the heck? Oh. We need the lifetime here. I guess I could just static, maybe? I don't know if that would work. But can I actually mutate this? Can I say public? Okay, what if I set state here? Cannot borrow immutable static item state as immutable, cannot borrow. Okay, but what if I want to make it mutable? Do I need to use some bind by reference during pattern matching? Should it be mute maybe or something like that? I don't think this allows it. Oh, I need to use a mutex here? Really? Interesting. Okay, let's try mutex then. Where is it? This is what you get with global stuff. Alright, so mutex. But then I think we would also need an arc, right? I don't know honestly if it is really worth it that much. Okay. So how do you use mutex again? I forgot. Dot lock, okay. Is that how it goes? Borrowed data escapes outside the method. Escapes the method. Oh crap. I would probably guess we're gonna need the arc mutex. I don't know, man, if this really worth all this trouble. Expect, okay. So say dot clone maybe, then dot lock, dot then dot in wrap. Expected mutable reference. Mutex card, okay. We do a dir for mute here. Source must outlive static. Okay. Oh, really? Does this at least compile? I mean, at least this part compiles. But if it really works, no clue. Well, right now we gotta say state dot clone dot lock. Oh crap. Okay, please just work at least. Yikes. That seems like a deadlock to me. I think I know why. Maybe I know why. Maybe I know why. Because basically I think we're getting the lock here, right? And then maybe we are again going here and taking the lock again. Well, this became multi-threaded, bro. Oh man. When this crap became multi-threading, I have no clue. I don't think this would work either. Huh. No way. No way. Yep, no way. Well, this doesn't really seem like it's working. Is there some other way that we could possibly do this? Other than a mutex? What about an RW lock? But I think it's gonna be the exact same result. Yeah, no way, bro. So you know what? I think we're just gonna remove operator overloading at least for now. Man, that suck. Anyways, so let's remove this trash. Okay, so hopefully GitHub Copilot could help us rewrite this real quick. Okay, parse with states, pass in mute state. Oh, hold on. Oh, I mean, we can reuse the same state. I don't think there's gonna be a problem with that, yeah. It's just gonna keep on growing. Expected use size found expression. Huh? Oh, crap. No. Yeah, honestly, I think to make this work really, I think we gotta make a builder pattern to constructing ASTs really. So right now we're gonna need some sort of another abstraction to build ASTs easily. So yeah, honestly, I'm not gonna rewrite this because it's gonna be wild. Because right now what I'm gonna need to do, I think, is to essentially say, I mean, yeah, you just gotta say box mutable state, right? Yeah. And you gotta do it all over the place. So yeah, I think honestly I'm gonna wait until we can until we make some abstraction to make ASTs easily, and then we can rewrite the tests. Sucks that we're not gonna have tests for now. But there you go. So no operator overloading for you. Okay. I tried. I tried, but I failed. Now, if anyone is more advanced in Rust, please let me know if there is a way to do this. So there you go. But does this work at least? I think it should. What? Why? Okay, negate 0. Okay, negate 1. What? What is even that? Oh, I see. So right now we're gonna actually make an EQ, a custom EQ implementation for this. Because right now it's actually comparing references, right? So basically in our case it's index, right? But they're basically not the same allocation. But then even if we try to use like implement EQ, a custom EQ implementation for this, we're gonna need the state. But EQ doesn't have this. You cannot get this. I didn't think it would be that crazy, isn't it? Interesting. Well, yeah, I see. So no tests at all for now. Okay, the cost of performance. For now, we're not gonna have any tests. But at least you have this one example, this one test for now. So it's just evaluating and checking if everything good, right? This is not the full allocations though, because the calls actually have their own, but well, it's close, I guess. So yeah, I think honestly we're probably gonna stop here until we continue tomorrow. We haven't worked on the user experience stuff just yet, but we'll work on it tomorrow maybe. So it's already been 2 hours. But yeah, that was a lot of fun. Maybe a bit painful, but yeah, we have done something cool today, I guess. We have saved some allocations. And yeah, that was it for this stream, I think. Let me just so we got Chumsky. Okay, is there anything we have changed? Not really. So there's actually nothing to change here other than the allocation, but it's not a big deal. So yeah, that should be oh crap, I'll change this. Sure. So I'm just gonna push everything, all the commits that we have done right now, and we're good to go. Cargo r dash dash example basic. There you go. So yeah, that was it guys for the stream, and see you later. Goodbye everyone.